All right, so the first thing we're going to talk about, 9.5, which is homework 17, is the dot product. So in order to find the dot product, again, this is a formula that's not given to you. You need to know. You have to multiply your horizontal components together. And then you multiply your vertical components together and you add them. So this, I'm sorry. I passed that out.
Oh, is it this one?
Yeah. Okay, so this will be your x1, y1. This is x2, y2. So we're going to multiply our x's and multiply our y's. So that will be 3 times negative 2 plus 5 times 4. See what you get. So I multiply my x values and I multiply my y values, which are my vertical components, and you add them together, which is negative 6 plus 20 or 14. That would be your answer. Any question? Do example 2 on your own. Find the dot product. You should get 11. So that's important because you also need to know how to find the angle between vectors. This is the formula on how to find the angle between vectors. You have to find 3 things. The numerator, this means find a dot product. So first we have to find the dot product. Remember, the double absolute value, that means magnitude. If you ever get a dot product of 0, then that means the vectors are orthogonal, which is a very fancy word. But all it means is that it forms a 90-degree angle. So we got 2 vectors. Let's look at example 1. Example 1, I have vector v and w, and I want to find the angle between these vectors. Step number 1, find your dot product. So you're going to multiply your x's together, multiply your y's, add them together. So that's the first step. Go ahead and find that number. Which is the exact same one that we just did. So that would be 3 times negative 2 plus 5 times 4, which is 14. So put that to the side. The next thing you need to find is the magnitude of vector v. So magnitude of vector v is going to be the square root of 3 squared plus 5 squared. See what you get? Just leave it under a square root. Do the same thing for vector w. All right, go ahead and find those 2 numbers. So 9 plus 25 is 34. 4 plus 16 is 20. If you put it in your calculator, it simplified it. Either way is right. It's fine. So now what I'm doing is I'm taking these three numbers and I'm going to find the angle between vector V and W. So to do that, because I'm looking for an angle, that means I take the inverse cosine. Remember, angles are always inverse. So the angle is going to be the inverse cosine of your dot product is in the numerator. And then you're going to take the square root of 34 times 2 times root 5. Type that in your calculator. I rounded mine to the tenths place, but you follow the directions on your test. I'm pretty sure it says thousandths place. Take a moment and type that in. So you should get something close to 57.5. Again, always look at the directions. If it has a rounding place, that's what you round to. I didn't specify it in the notes, so I just rounded to the tenths place. I guess, I don't know. All right. Unless it was like 57.499 and something, I don't even know. But anyway. Let's go on to the next one, example 2. Find your dot product first. All right, who got 0? So remember, what did I say? Anytime your dot product is 0, that means that the angle is going to equal 90 degrees. So you don't need to go any further. I mean, you can, but you're kind of wasting your time. Because when you take 0, and if I divide 0 by anything, it's going to give me 0. So if my numerator is 0, that means that I'm taking the inverse cosine of 0. And the inverse cosine of 0 is 90 degrees. So that's the angle. So that tells me that vector V and vector W, again, they come together and form a right angle. So my answer is 90 degrees. All right, go ahead and start example 3. Try to do the whole thing by yourself. But I'm going to get you started because I know you might get confused in the beginning. But for vector V, notice it says 3i plus 4j. Remember, 3 is your horizontal, 4 is your vertical. So you could just write it as V 3, 4. That's your horizontal and vertical component. It's another way to write a vector using I and J. Vector W, -6, -8. So what I want you to do is find your dot product and the magnitude of both vectors. Did I show you all your tests yesterday? Yeah. Okay, I did. Okay. So that's what I got. Who got negative 50, 5, and 10? All right, go ahead, type it in your calculator. You should get 180 degrees. So that means that vector V and vector W, they form a linear pair, or they come together and create a straight line. That is my angle. All right, just a few more and then we'll end there for today. You will be able to do all of homework 18 after today, but we are going to finish a few more questions tomorrow. Homework 18 is not due until Monday. Test next Friday. All right, so now let's talk about work. Formula for work is simple. It's force times your displacement, which is distance, cosine of angle. So again, this means force. And this stands for your distance. Very simple formula. Extremely simple. So question number 1 says, a boy pulls his brother in a cart with a force of 22 newtons. I'm going to stop there and circle that. That's important. If the rope pulling the cart forms a 38-degree angle, that's important. That's my angle. With the ground, determine the amount of work done if the boy pulls the cart 25 meters. Work equals force, 22, times distance, 25, times the cosine of the angle. Type it in. So when I type that in, I got 433.4. Who got that? Something close to that. All right, do example 2 by yourself, or number 2. Read the question. I'll read it out loud. Find the work done by a force of 3 pounds acting in a direction of 60 degrees to the horizontal, moving an object 9 feet. All right, I got 13.5 or 27 over 2. All right, last one, number 3 for today. So it says that an airplane has a horizontal component of 300 miles and a vertical component of 500 miles, resulting in a magnitude of 583. So that means that the speed of the plane in still air would be 583. However, we do need to take into account the wind, okay? The wind is blowing 40 miles per hour, which is the magnitude. Now, this is what's kind of confusing, where it says from the east. Okay, circle that. If I tell you I'm coming from the east, what direction am I going? West, right, yeah. So going back to our never eat soggy waffles. Never eat soggy waffles. That means I'm going this direction. Okay. What is the angle? Go back to the unit circle. What is the measure of this angle right here? 180. Because remember, 0, 90, 180, 270, 360. So that tells me that the wind has a magnitude of 40 and the direction is 180. So what we need to do is we need to write a vector for the wind. And I don't know if you remember going back, but I gave you this formula that said delta x is equal to magnitude cosine of theta, and delta y is magnitude sine theta. So let's go ahead and write our vector for the wind. So we got our wind. So that's going to be 40 cosine 180 and 40 sine 180. So take a moment and find your horizontal and vertical component for the wind. So that gives me negative 40, 0. And they told me in the first sentence that the airplane had a horizontal component of 300 and a vertical component of 500. So what we need to do is add these together. And let's write a vector for the plane plus the wind. Plane plus wind. So take a moment, add together your two horizontal components and your two vertical components. So negative 40 plus 300 is 260. 0 plus 500 is 500. Okay, now you're going to use that and find the speed or the magnitude of the plane plus the wind. So the magnitude of the plane is going to be 260 squared plus 500 squared. Go ahead and see what you get. And your direction is the inverse tangent of y over x. So go ahead and type both those in. That's always the formula. Go back to page 2, I think, where I gave you the formula for speed or for magnitude. Page 2, page 1. It's always tangent. So the speed of the plane is 583, but because it's flying against the wind, the plane's new speed is about 563. Magnitude and speed are the same thing. 563.56 or 0.6 miles per hour. That's my magnitude. The direction is 62.5. But this is really important. Make sure you write this down. Anytime it asks you for heading, right? And if you look here, notice it didn't ask me for the direction. If it said find the speed and direction, we would be done. But it asks us for the speed and the heading. So you have to take 90 minus the 62.5. Only when it asks you for heading. So my heading for this example is 90 minus 62.5, which is 27.5 degrees. These would be your two answers. This is what I'm looking for on the test next week. If it says heading, only if it says heading. Any questions?